Today we are going to talk about greatest common factor. By the end of this lesson, I hope that you are able to find the greatest common factor of two whole numbers that are less than or equal to 100. So let's start off with some vocab. Factors. Factors are what we multiply to get a number. So for example, if I have 2 times 3 equals 6, 2 and 3 are my factors. Okay, so 2 and 3 are multiplied together, so those are our factors. Common factors are factors, like 2 and 3, that are shared by 2 or more numbers. So we'll look at some examples of that in a moment. The big thing here is that greatest common factor, typically referred to as GCF, greatest common factor. And GCF, greatest common factor, is exactly what it sounds like, greatest. The GCF is the largest, the highest factor, the highest number that's multiplied together that two numbers have in common. Okay, so let's take a look at some examples. Let's start here. We have the GCF of 24 and 40. So we can find the GCF in two different ways. We can find the GCF using lists or using prime factorization. I will model both, ask that you try both, but eventually you will pick what makes you more comfortable. All right, so when we use our lists, we want to think of that number, 24, and what numbers that we multiply together, whole numbers, will equal 24. So I always start with 1 and 24. Okay, now there's a couple of different ways to make these lists. This is how I do it. But you can do it in several different ways, and I can show you some options. Okay, so 1 and 24, okay? Then you can connect those if you want, okay? Those multiplied together will get us our number. Then I just go up in order. What comes after 1? 2, okay? Does 2 go into 24? It sure does. 2 times 12. Again, if I would like, I can connect that with a little rainbow arc right there. All right. 1, 2, 3. Does 3 go into 24? Yep. 3 evenly goes into 24. If I multiply 3 by 8, I will get 24. I go up to my next number, which is 4. Yep. 4 times 6 equals 24. And then I go to my next number, 5. 5 does not go into 24. So I can figure that out by saying, okay, 24 divided by 5, is that going to be a whole number? No. 24 divided by 5 is not a whole number. So therefore, I cannot go on to 5. My next number is 6. Well, I already have 6 on the other side of my rainbow. So I have now listed all of the factors. There are no more. I don't need to try 7 or 10. I've already exhausted all my options when I go in order like this, okay? If you kind of jump all over the place, then you should definitely continue double checking. But when you go in order, you have already gotten everything you need. All right, let's do 40. So again, I start with 1 and 40. 1 times 40 equals 40. 2, does 2 evenly go into 40? Yes. 2 times 20. Okay, next, 3. Does 3 evenly go into 40? No. So I skip it. I move on to the next number, which is 4. Does 4 evenly go into 40? Yes. 4 times 10. I go to my next number, which is 5. 5 times anything? Yes. 5 times 8. All right, next I've got 6. 6 times anything equal 40? Nope. Next number is 7. 7 also does not evenly go into 40. So then I'm back to my 8. which connects to my 5. So I do not need to continue. I have listed all of my options. So I look here for the common factors. Well, 1 is common, 2, 4, 8, and that's all we got. All right. Now we want the highest factor they have in common. So that would be 8. Our GCF, our greatest factor that matches, is 8. So we made our list of factors determining which numbers multiplied together get our number that we're working with, came up with our 2 separate lists, compared them, and found the largest number that they shared. Prime factorization to find GCF is slightly different. Let's try. We start by just doing our prime factorization. So I start with my primes, 2 times 12. 12 can be broken down into 3 and 4. 4 can be broken down into 2 and 2. So here we've got 2 times 3. 2 times 2 times 3. Alrighty. Let's look at our 40. Starting with my primes, I've got 2 and 20. That can be broken down into 2 again and 10. Then I've got 2 and 5. And then that's where I stop. So now I have 2 times 2 times 2 times 5. Okay, so now I'm going to write these 2 prime factorizations on top of one another. And this time I actually look to see what they have in common, which is 2 times 2 times 2. And from there, I multiply those. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So my GCF is 8. So when I use my prime factorization method, I do the work towards getting the prime factorization of each of my numbers. When I've got my prime factorization, I line them up, find what they have in common, multiply those together to get my GCF. All right, so let's try it with a 3. Here we've got find the GCF of 36, 18, and 45. So again, I can make my lists 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So 6 and 6 multiplied together equal your 36. So if you were to be making those little rainbows, I would just make a little guy like that. We will not write 6 twice. 6 is not its own, it's a separate factor. 6 just multiplied together is 6. So we would just leave that 6 like that. All righty, let's go ahead into 18. We've got 1 and 18, 2 and 9. That's all we got for 18. Then we've got 45, 1, 45. 2 does not go into 45 because 45 is odd, but 3 goes in. We've got 15. 3, 4 does not go in. 5 does. 5 times 9. Again, 6. I continue going up. 6 does not go into 45. 7 does not go into 45. 8 does not go into 45 evenly, so I am done. Now I look for my factors that I have in common. I find the largest one, which in this case is 9. So my GCF is 9. All right, let's try it with prime factorization. We've got 36, so that would be 2 and 18, 2 and 9, 3 and 3. I'm going to write these over here this time. We've got 2 times 2 times 3 times 3. All right. Then we've got 18, 2 and 9, 3 times 3. Again, I'm going to write those over here. 2 times 3 times 3. And then lastly, our 45. Let's break it down into 5 and 9, 3 and 3. All right, so here we go ahead and write that out. 3 times 3 times 5. Again, I find the numbers that are in common, and they each have 2 3s. So I would do 3 times 3, which equals 9. So my GCF is 9. Like I said before, you are welcome to use either method. I recommend trying both and seeing what you like.